Welcome to The Explainer. Today we're diving into something that sounds a bit like science fiction. What if getting older wasn't something we just had to accept? We're going to look at a whole new field of science that's trying to treat not just the diseases that come with age, but the process of aging itself. And folks, if this works, it could change, well, everything.
So let's jump right in. For pretty much all of human history, medicine has been playing a game of whack-a-mole with getting older, right? You treat the heart disease, then the arthritis, then the dementia. But what if, instead of fighting all these separate fires, you could go after the arsonist who started them all?
And that brings us to this really radical new perspective. It asks a question that kind of flips everything on its head. What if aging itself isn't inevitable, but is actually a treatable condition?
You know, a leading researcher in this field, Dr. James Kirkland, he's a geriatrician. So he sees patients all the time who don't just have one thing wrong, but a whole list of chronic problems. They call this multimorbidity, and it often leads to patients taking handfuls of pills every day, something called polypharmacy. The real goal here is to get to the root of that, to reduce that huge burden.
This is the big idea behind a field called geroscience, and the thinking is actually pretty simple, but the implications are absolutely massive. The idea is, if we can target the fundamental biology of how we age, we might be able to slow down, prevent, or maybe even treat a whole bunch of these diseases at the exact same time.
Okay, so what exactly are scientists targeting? Well, one of the main culprits is something with a seriously cool and kinda creepy name, the zombie cell. And yeah, they pretty much do what you'd expect. Now, the story of these cells, their technical name is senescent cells, it actually started way back in 1961. For a long time, scientists knew they existed, but kind of figured they were just old, retired cells, not doing any harm. The big aha moment came much later, when researchers figured out these cells weren't just sitting there, they were actively causing a ton of damage.
And what's so fascinating is that these cells are totally a double-edged sword. When we're young and healthy, they're crucial. They do important jobs like stopping a damaged cell from turning into cancer. But as we get older, they start to hang around way past their welcome. And that's when they turn bad, spewing out this toxic gunk, scientists call it the SASP, that damages all the healthy cells around them. It's wild.
So, if our bodies are slowly getting overrun by these toxic zombie cells, the next question is obvious, right? How in the world do we fight back? And this is where the science gets just so clever. The researchers asked this amazing question. They said, hold on a second, these cells are pumping out all these toxins that kill the cells around them, so why don't they die too?
And this just lays out the genius of their strategy. The drugs, called Senolytics, they don't attack the zombie cells directly. Nope. Instead, they act like saboteurs. They sneak in and just temporarily turn off the self-defense shields these bad cells put up. And once those shields are down, the cell's own toxic sludge basically causes them to self-destruct. It's beautiful.
The idea is so elegant, and it works like a charm in the lab. But of course, that leads us to the billion-dollar question. Can we actually make this work safely and effectively in people? Because we're talking about a completely new type of drug, you have to be incredibly careful. The #1 rule in medicine is, first, do no harm. So you don't just start giving these things to healthy people. You have to start with patients who are really sick, who are suffering from conditions with no other good treatments. And this list shows you what that looks like. The first human trials are targeting these just devastating illnesses, right? Things like Alzheimer's, fatal lung diseases, deadly brain tumors. These are all conditions where these senescent cells are thought to play a big role, and where the potential upside of a new treatment could be huge.
So what's the end game here? You might think it's all about living forever, but interestingly, for researchers like Dr. Kirkland, it's actually less about our lifespan and way more about our health span.
This quote from Dr. Kirkland just says it all. You can feel the frustration. He spent years treating the symptoms of aging, the walkers, the devices, and he wanted to get to the root cause. The goal isn't just to add more years to life, it's to add more good, healthy, vibrant life to those years.
When you ask him to put odds on this whole approach, Dr. Kirkland is really honest. He thinks there's about a 30% chance that geroscience could completely transform healthcare as we know it. I mean, think about that. That's a change bigger than the discovery of antibiotics.
But, and this is so important, as a scientist, he stays grounded. He also says there's a 70% chance it just might not pan out in humans. What works in a mouse doesn't always work for us, and that's why these clinical trials are absolutely everything. They're the only way to know for sure. So in the end, yeah, the science is still young, but it's already making us ask these huge questions. This research really challenges the idea that aging is something we just have to put up with. It reframes it as something we could potentially treat.
It's not about living forever, it's about living better. And if it works, just imagine how that could change what it means to grow old.